Let us take one more example of acceleration. A train starting from a railway station and moving with the uniform acceleration attains a speed of 108 km per hour in 5 minutes. Find its acceleration. Now it is given that it is starting from a railway station. That means initially the train was at rest. So it is 0 meter per second, and moving with a uniform acceleration attain a speed of 108 km per hour. So final velocity will become 108 km per hour. We will convert in meter per second by multiplying it by 5 by 18. So 18 6 so 6 into 5 30 meter per second. Time is given 5 minutes. It has to be converted into second because speed we have taken in meter per second. So 5 minutes, that will become 5 into 60, and that is equals to 300 second. Now we have to find the acceleration of the train. We know the formula of acceleration, and that is equals to A is equals to V minus U upon T. So acceleration V, final velocity is 30 meter per second, initial velocity is 0, upon time is 300 second. Let us solve this. A is equals to 30 minus 0, 30 upon 300. This will cancel. 3 upon 30, that is become 1 upon 10, and 1 upon 10 is 0.1 meter per second square. So the acceleration of the train is 0.1 meter per second square. Now let us take one more example of acceleration. Starting from a stationary position, Ram pedaled his bicycle to attain a velocity of 8 meter per second in 40 seconds. Then he applies brake such that the velocity of the bicycle comes down to 4 meter per second in next 4 seconds. Calculate the acceleration in both the case. There are two cases here. So case number 1, case first, initial velocity. It is given in the question starting from a stationary position. So initial velocity is 0 meter per second, and final velocity is Ram pedaled his bicycle to attain a velocity of 8 meter per second. So final velocity is 8 meter per second, and time is 40 seconds. So let us calculate acceleration. A is equals to V minus U upon T. So A is equals to 8 minus 0 upon 40. So acceleration will be equals to 8 upon 40. So we'll cancel this. 8 ones are 8 upon 8 5s are 40. So this becomes 1 upon 5. And when we'll solve this, acceleration will become 0.2 meter per second square. Now in this case, when the speed is increasing, the acceleration is 0.2 meter per second square, but he applies the brake and the velocity comes down to 4 meter per second in next 4 seconds. So now here in this case, the initial velocity is 8 meter per second, final velocity comes to 4 meter per second, and the time is 4 seconds. So now we have to apply the same formula, that is acceleration, that is V minus U upon T. So V is 4 minus 8 upon time is 4. So A is equals to minus 4 upon 4. So acceleration is minus 1 meter per second square. Here you can see that when this velocity is increasing from 0 to 8 meter per second, the acceleration was positive, that is 0.2 meter per second square. And when the brakes are applied, the velocity is decreasing from 8 meter to 4 meter per second. That means the velocity is decreasing. So in that case, the acceleration will be negative, and in this case, it is minus 1 meter per second square.